Welcome to the Resairchia YouTube channel. My name is Jorge, and in this video we will continue with Pythonian Physics and developing our little simulator. As you can see, I have added a few things to the interface. Mainly these three list boxes for showing our results. I will go through the code to explain what I have done. First, we can see here the three list boxes that I have added. The explanation is pretty straightforward. We will have a variable with the values. We declare the list box with some dimensions, its position, and in the first entry of the list, we add some string to explain what each list is showing. Something that is quite important is that you need to pass our variable with the results, and you need to declare the export selection false. The reason for having this is that if we click in any of the list boxes, as I will show you later, we could get an error when we deselect one of the previous selections. I will show you in a minute what I mean. I will start by copying our test equation as I have done in previous videos, add an initial time, the same stop time that we had before, and some time step. And then we simulate. In the list boxes, you can see now the initial value that our variable took and its ending value. However, you can see that there is no variable names here. For that, I have added a few extra lines here. Let me show you what they do, and then I will go through them. So we tell to the parser, like this, that we are naming our variables. In this case, only one. Why? So now we simulate again, and you can see that the variable name appears here. When we click on it, we can see our result. I will show you as well how I change the way I plot things. Now that we have the variable name here, I can show you what I meant when I talked about selecting different things in the lists. So as you can see, when I click on a different positions, I get some info. I can click on these ones, but nothing happens. And then I can click on Y again. As you can see, we get our plot, but we are also getting these ones and zeros here, depending on the position we are clicking here. That's because we are keeping track of the position in the list where we are clicking on for the plot later on. As I said, you need to have these export selections as false, otherwise you could get errors when clicking on the different lists. So now that we have gone through the possible issues when clicking on the lists, I will go back to this way of naming variables. So first, what I do, every time I simulate, I clean the list boxes. Basically because we don't want to mix results. So I'm using again regular expressions for finding things in our equations box. With this line, we are telling the parser what it needs to find. It needs to find this structure, and this means that any character in between one or more times will be added to what we are searching. Then, if the previous line is not empty, meaning that we have found our variable names, we simply substitute these two parts from the variable names group that we have captured using the regular expressions. I will leave a link in the video for a very good website where you can read about regular expressions in Python. And then after finding our variable name or names, we add it to the list box. We will improve this in future videos by adding more variable names. With this line, we just remove the line with the variable names so the parser doesn't get confused when we send the system of equations. You already have seen many of these lines. However, we have changed these ones. First, we have changed the time limit. If you remember in the previous video, it was a fixed time limit. Now the time limit will be the same as the one we write in the stop box, meaning that we can run very long simulations or very short ones. Once the simulation is done, we populate the lists. This line will take the first value of the variable that we have solved, and this part will take the last value. That's what the -1 means. It takes the last value of the array or vector. These couple of lines here, they don't need a whole lot of explanation. You can Google what they mean, but basically is if we expand our window, things will stay like this. I will deal with the different boxes in future videos and show how to expand them at the same time we expand the window. Now the next thing is, as you have seen, what happens when I click on the different boxes. To be able to do so, we need to define a function that I have named clickEvent. What we do is, with this part, we tell the get function the position we need to get from the list box. I am not using this variable anymore, but I'm keeping it in case you want to try yourself. This print is here to show what position we are selecting. If you remove this 0, you can see that you get a small array. That's why I have the first 0, because we need only the first position of the array. Then I use that again to keep track of the position that we have clicked on, and I pass it to this new function that I have created, the clicked position with the solution. The solution, as I have shown before, it's over here, but now it's declared as a global variable. By doing this, when we assign some value inside the simulation function, it will be stored and usable in other parts of our code. So we call the plot results function with the solution and the clicked position. With that, we have the plotting function here. I kept the old code from previous videos so you can compare with it in case you want to play with the code a little bit. Then I have this if else. The if removes 1 from the clicked position. Remember that our variable's name, the first position, is 1. To check if we are clicking on this line that says variable name, if we have not clicked on that one, we just show the plot. I have it like this because in the future we will expand our GUI and add the possibility of having several variables. The message box here, it shows some info telling us that we need to click on a variable to get the plot. And now we can have different setups for our simulation and compare the results. You can see that if we change the step size, our function changes its shape. In future videos, I will show how to add more variables, more equations, and so on. Thank you so much for watching and see you in future videos.